Talk about COTS, currently off-the-shelf technology, stuff you can just go out and buy that's all over the place here. And then a bit about homebrew and how to do that. That's really the most important thing in an emergency situation. All right, emergency situations. I've broken them down into this, you might argue, but we've got a local, regional, interstate, and intrastate. A local would be, 20 miles around. More than likely, you've already drilled with the Emergency Operations Command. You know how to do that. You probably already have your stuff ready to go. Most likely, local is going to be done with 2 meters and 440. Actually, low bands is probably not even useful in a local situation. In a local situation, you may have loss of infrastructure, loss of repeaters, actually. Even Emergency Operations Command may lose theirs. We had a tornado that came right through this fairgrounds, I think it's 2000, 2001, about that period of time, and it took out everything except ham radio. Fire, police didn't have communications, telephones went down, cell phones were useless for about a half an hour. We were able to jump in and provide immediate communication. So even in a local situation, you could lose everything. So, so being prepared is a good thing. We'll go into how to do that. You're probably already ready for that. Oops. The second is regional. This covers a bit more area. It may cover several counties in this area. Regional may spread over into Illinois as well. That could be a forest fire, floods, earthquake, or civil unrest. And held in it could even be a biological situation or even a loss of infrastructure, electrical and that type of thing. And in that case, you would still maybe use 2 meters, 440, but then you may jump into low bands, 6 meters, 10 meters, or 40 meters on a near vertical incident skywave. And we'll talk a little, who knows about NVIS, hands? Oh, good. Yeah, it's a very interesting antenna configuration and phenomenon. And then we have interstate. That's a national event. And in that case, you'll use a combination of things, including HF. Now, sometimes, it could possibly be in a intrastate situation that ham radio operators might be shut down and then all called up only on special purpose. And we had that happen in World War I and World War II. Haven't had since, but it could be because of a military conflict. I don't think so. We got the Second Amendment, right, Mike? A pandemic, I hope we never have that, but Ebola is starting again back in another country. We hope that doesn't spread. Major sunspot interruption. We had one in the 1850s, 1860s that took out all the telegraphs and so on. You can just imagine if we had another storm like that, which is possible. We'd lose satellites, we'd lose everything on the ground. That would be a big problem. And of course, everybody's talking about a meteor strike, and we think we know where they all are, but we don't know where they all are, and that could be a problem too. So again, setting the environments. You got a local, regional, intrastate, and interstate. So all require different types of antenna systems. Oh, who put that there? All right, very important, the antenna. As you probably know, the antenna launches energy from the transmitter into space. Aside from the transceiver, the antenna is really the most important thing in the whole system, the antenna system. When I say system, I'm not talking about just that dipole out there, but I'm talking about the feed line, the hardware, and so on and so forth. It all makes it up. We'll talk a little bit about that. And of course, then ask me questions as well. I pulled this out of the files. This is about 100 years old. That's the way they used to do it in the old. That was before photographs, so I just wanted to share that with you. All right, antenna design is a direct function of the operating frequency. Probably you know that, but we're going to hit that a little bit. Some of the newer guys that are network people think that there are antennas specially designed for digital especially designed for FM. But no, antennas are antennas. They work on every system. There may be some newfangled stuff coming out in the military with conformal and all that might work, but for the most part, antennas will work on any mode. Mike, you got a puzzling look there, so you just like it. Antenna safety. Since we're talking about antenna, did somebody laugh? Who knows who these people are? Hands up. Okay, so we don't have as many old people here as I thought. Yeah, that's Lucy and Ethel from I Love Lucy. Yeah. Hard to see? Okay, for you guys that can't see, it's Lucy and Ethel. Important, nearby objects. We get a lot of people cooked by dropping their antennas into the power line. Lightning and EMP protection is important. Physical installation is important. You don't want to these things fall on you if they're larger. There are radiation hazards. What's the most dangerous frequency out there for people? Can anybody answer that? Microwave, what'd you say? 60 cycles. Okay. Yeah, that's bad. Yeah, that could be bad. Dangerous frequency. How tall is the average person? 6 foot? A little more, a little less? That's how many meters? 2. We are resonant frequency to 2 meters. And if you do, you could be. You could be a reflector if you want to be. So, yeah. What, Joe? You thought that was funny? I didn't hear that. Grounding's important. We'll talk a little bit about that. Height, of course, if you could be climbing, in the case of emergency antennas, you're climbing trees, so you got to be careful. But if you're climbing towers, safety belts, and so on. And of course, lockout, tag out. You want this thing shut down until you fire. Particularly if you're running 100 watts on 40 meters, you really don't want to be on the end of the antenna. Yeah. All right, wavelength versus frequency, very important too. And we'll be talking about various frequencies. This is sort of divided by the IEEE definition of the various frequency ranges. I don't know if everybody thought about the spectrum being like this, but here's the whole spectrum being cataloged. So test question. Who knows about K-band here? Anybody work on K-band? Hands up. Okay, we got a few here. What is KU? It's below, yeah. So why do they call it KU? Yeah, but what do they call it? You got K and you got KU. No. What about KA? Why do we call it KA? KU means under K. KA means above K. Yeah, now you know. And that's way up there. What is that? K is 18 to 26 gigahertz. Boy, I remember the day when you couldn't even get up there. I remember when I'm carbon dating myself, 2 gigahertz required waveguides. There was no such thing as, you got coax now that'll go up to 10 and 15 gigahertz. Crazy. And that really works really well on low bands. I'm lucky enough to work with that, so I pick up the leftover stuff. All right, simply, antenna is very basic. All antennas, I don't care what they are a derivative of a dipole. And a dipole basically is the radiating elements, the end insulator, a center insulator, and the feed line couplings. It's the entire system. Now we see a vertical right here. You see one piece. How could that be a dipole? Well, the other part of the dipole, to make sure I don't get tangled up here, is the ground conductor, the radials. Important. If you're going to throw a vertical up, I know there's some that are non-radial, but they have another function with it. That's the other part of the dipole, are the radials. Okay, another thing before we get into the type of antennas for various situations, so on, is propagation. And some of you guys and gals that are extras, you probably know, particularly if you're doing DX contests and that type of thing. But propagation is the behavior of radio waves when they're transmitted and propagated through space. And radio waves are a form of electromagnetic radiation. But there's one other thing that influences propagation more than anything else. What is it? Very good. You get an A for that one. The sun. Very, very important. And the sun creates another thing. And, we talk about the atmosphere, and the upper part of the atmosphere is called the ionosphere. Anybody know why we call it the ionosphere? Ions, yeah. So, okay, I don't have to ask this question. Why is it called that? Of course, it's made up of ions. What's an ion? Right, there you go. I got a physics guy here. Negatively or positively charged particle. Can be anything on Earth or whatever. In the case of the ionosphere, it's mostly the water vapor that's up there, up high. It's real loose. And the sun is extremely strong, and the cosmic rays and all kinds of other crazy stuff up there, and they strike the water molecule and split it apart into positive and negative, and then we get when it goes back together, kicks off an electron. We've got this big mirror made of electrons up there, and we're able to reflect radio signals from it. And then, of course, I'll talk about the minute, but then that's what causes the aurora borealis and the Australia borealis, or something like that, the aurora australis, I think, down south. This is a depiction of the ionosphere, day and night. It does change during the daytime. The F layer and the E layer are, the F layer is together, but then in the daytime, when the sun heats it up, particularly the F layer splits into 1 and 2, and then this has a relationship between the frequencies that you operate on and can reflect off of that. Where are the A and B and C layers? Huh? They didn't find it. He's right. He knew we had the higher level. We thought there might be lower level, but they've never been discovered. It's kind of what we breathe here. And of course, the aurora is formed. Here's a beautiful picture of the aurora, and that is when we really have a strong sunspot disturbance. The sky will really light up. If it lights up clear down to Ohio, you really got something going. Maybe good, maybe bad. When it first occurs, you don't get anything, and then a couple of days later, we get all kinds of reflections and crazy stuff going on. There are a lot of elements to propagation. A few of them, there's reflection, or just striking an object and reflecting off, refraction or bending, diffraction, spreading it. Also, objects will absorb. We'll talk a little bit about that. Of course, there's an important part of polarization, scattering, solar effects, and then I found a few other things here. What's called Earth ionospheric waveguide, where signals may find a path and actually go right through it like a waveguide. This occurs a lot in the fall, although with these storms we have going in and out here, these spot storms, we get a lot of moving past each other and forming sporadic E and acting like a waveguide and a reflector altogether. There's fading. There's ionospheric absorption. The ionosphere can absorb your signal and just absorb it and not reflect it back. Then there's ionic scintillation, where there's fluctuations in the ionosphere. Sometimes we can hear this when we point it at the northern lights, and it'll kind of warble. Line of sight propagation can be affected by various physical elements. And then I ran into this one, Cifrix. I'd never heard of it. Have anybody heard of that term? That's actually radio signals being created naturally, mostly by lightning and electrostatic discharge, that as we're up there, we can hear these signals coming back and forth, and they're all created in the natural system, and it will interfere with us. Okay, before we get into the antennas themselves, the most important elements of antenna, first of all, length. And I mentioned before, length is a function of the frequency we operate on. Also, width is important, not as important, but it has an effect. Height above average terrain, surrounding objects, connection integrity, and grounding. On length, I said it's the most important factor because it's a function of frequency, and most antenna designers like to talk about half-wave dipoles and quarter-wave elements, and a very, very easy thing to remember. Remember this, 468, who do we appreciate? 468. Remember those numbers. We're going to show you a little trick here, and it looks like this. If you want to design an approximation of a little bit longer than you need, halfway dipole, very important on an emergency situation, you just take 468 and divide it by the frequency in megahertz. Okay? So we'll get it. We're going to do a couple of problems like that in a minute. It's very, very simple. 468 divided by the frequency in megahertz, and you get the length of a half-wave dipole. Okay? Remember that. 468 divided by the frequency in megahertz. So if you're out there and you got a radio and a ball of wire, you can get on the air. We'll get into that. All right. All right, let's look at the ham bands just a little bit. All right, so the ham bands basically are this. There are other ones as well. So I get back to my quiz question. You have 10, 20, 40, 80, and 160. They look like double multipliers of each other, right? Who can tell me why the ham bands, the original ham bands, were split that way? Harmonics, okay, but what's it got to do with it? Come on, give me a hand here. I want to see. Why are they split that way? One antenna for anything? Sorta. Give me another one. Got to go back further than that. Give me another hand. Who knows why they're split this way? Yes, sir. Yes, that's correct. But you left one other element out. Back in the day, the oscillators are based on what? Crystal, right. And so you could buy one crystal and cause it to oscillate on these various bands, and they're multiples of each other. So that was a way of doing that. Plus, you could, play with the propagation. So it had to do with you purchase a single crystal and you could play with it on those various bands. So they were split that way. Now it's different with software-defined radios and everything. We can do whatever we want these days. But also, you can see here in terms of the halfway or the quarter wave, the lengths double as you go up through there too. Again, function of the frequency we're operating on. Width is important too, but not as important. The thicker or wider the antenna, the broader the bandwidth. So some broader antennas, you might see 4 wires running, which will give you a little bit broader bandwidth. Height above ground, important to know too. If you get it above a wavelength, then your antenna approaches 75 ohms and stays pretty consistent there, but it's different on different heights. So getting it up a wavelength is good, but then trying to get 40 meters or 80 meters up the wavelength, you're getting up pretty high. So you're going to get some interference by that. Sort of related, 75 ohms, 50 ohms. So coaxial cable is what? 50 ohms. Why? Anybody tell why? Huh? Yeah, the radios are designed for that, but yeah, you have to crank back a little bit. Can anybody tell me why? Yes, sir. Exactly. How do you know that? Okay, Joe, who made that discovery? I think it was the Germans in World War II, but their coax they just developed was I think 35 or 40 ohms. Joe's right; it's in between. Why is your TV cable 75 ohms? Huh? You can hear the best on 75 ohms, but you can't. If you try to pump 1,000 watts through a 75 ohm cable, it's going to blow up. But if you pump 1,000 watts through, say, a 35 ohm cable, it's going to be happy. So here in the United States, we pick 50 ohms as the middle sort of type of thing. So all of our cable, now the world runs on 50 ohms, 50 ohm cable. So thank you, Joe. I got these plants out here. In fact, I thought about Joe, and I forgot, I left the propagation thing, but okay, right now, if you want to know about propagation, how your signal's going, you get on the internet and you type in some stuff and it spits out, oh yeah, we got a band opening in that direction, or you listen to the beacons and so on and so forth, but yes, sir. 300 ohm, it's very low loss, and so you'll just have to transform it, and yeah, and it's easier to tune. Joe, go ahead. Say, I can't hear you. It also matches 300 ohm. Yeah, It matches the 300 ohm folded dipole as well. It's all a matter of impedance matching and so on. But it's probably the lowest loss system as well when you're using the twin line. So Joe back there, the guy that's helping me, one day he pops up and he gives me a handful of these books. Some of them went back to 1940s. One of them was actually considered top secret at the time. But this is a table of propagation depending on the weather and the time, the sun activity and the sunspots and so on and so forth. Back in the old days, you have to just go look it up and look at these maps and so on. Okay, surrounding objects, very important too. Surrounding objects can affect the antenna design, the antenna choices. I pulled this out of the 2018 February QST, giving credit to Kai Swick and Richard Quick, who talked about a really good article in there about the effects of trees. So if you're going to be out there doing emergency work, you're probably going to want to use something to get your antenna up there. But you've got to think about this, that a tree, of course, is made of wood, and inside that wood is capillary pipes that move water up and down. And so a tree can be almost like a metal structure, but not quite as predictable as metal. Consider that a tree has sap in there both winter and summer. Of course, you can move away from the loss by moving away from the tree. Also, the forest. If you're in the middle of a forest, it can attenuate a signal. So if you're in a very emergency situation, you really want to move out of the forest if you could move into a clear area as well. There is some variation in summer and winter. You probably all saw this, particularly on UHF, when the leaves are on the trees. Right, Gary? It's tough to talk to you across town when I'm on there going to work, right? Yeah. Gary's one of my buds in the morning. We have this kind of a technical network. Who's here from the technical network in the morning? I got all right, very good. Phil's here. Just you two, huh? Joe, but what do you do? Listen to us in the morning on Huber Heights, and Ruben, who's not here, and Larry. We're going to get Larry, right? He has no excuse. He's not. Okay. So, yeah, 440. So, of course, keep the antenna clear from trees as much as possible, but you can use them to elevate your antennas into the trees as well. And then, of course, my friend WSAG is not here right now, but he did some experiments when he was in the Air Force getting his master's degree in EE with Nimbus antennas. Okay, there he is. Hey, Rick. Hey, I meant a WS8D. Is he here? You say he might have shown up. Yeah, just pick me up clear out of the field there. We're called the Whiskey Sugar Brothers, right? And so compliments of Rick. Canyon effect. You can get into hills and valleys, but also if you're inside a city, you can get involved in the canyon effect, and we'll talk about how to get out of there here in a minute. Grounding, also very important. It gives you a kind of a counterpoise to reflect from, and also adds safety, gets rid of your static, and so on and so forth. Mention connection integrity. Obviously, the less connectors you use, the better off you are. Connectors do act like little resistors in the system and can really drag things down. Antenna configurations, you probably know this, horizontal and vertical and circular. Just one thing, orientation is important. Going from horizontal to vertical is about a 20 dB difference in signal. Particularly close in. When you get further out, it's not as important. Closer in, it is. Then there's circular as well. And circular mostly is used when you're doing satellite contacts, because satellites are spinning in space, and you use a circular antenna to kind of chase that signal. All right, reviewing again. When you're building antenna systems for emergency operations, you've got to consider whether you're in a local emergency, a regional emergency, intrastate, or interstate. So that makes it dependent on what you're going to use. Okay, so your availability of antennas. Well, you've got the instant antenna, and that's a mobile station, or the currently off-the-shelf systems, and homebrew. Instant, well, it's as simple as this. If you're working in a local area, pull up your car, you got the battery, everything's ready to go, you're off to the races. Immediate type of system. Now, if this doesn't work, you can do this. Or if you're lucky enough, you can have one of these. All right, currently off the shelf, just being part of the Hamvention organization, I got to roam around yesterday before the crowds came, but lots of stuff here. A lot of stuff over in the flea market that you can make, or a lot of stuff to buy as well. Real cool. So currently off the shelf, there's an organization called iPortable. I think that they may be copying another company, but this is a total package system. Buddy Pole first came out with their portable system, really nice, high quality. If I'm not mistaken, Buddy Pole came out firstly to serve the Yaesu 817 radios for a while, and they worked very, very well. My son has one. Christopher, are you here someplace? He abandoned me. But he's got one, and I played with it. It's a really nice system. Crank IR. Rick, is that familiar? You can't leave your stuff laying around without somebody photographing it. Another quick off-the-shelf portable that works very, very well. Rick, you talked around the world on this thing, didn't you? I occasionally find this at Hamvention. I didn't see them this year. They're probably out in the flea market. These are actually poles that are used to pop up camouflage around a tactical operations center. And Bill? They come with a stand and a bag and all that kind of stuff. I highly recommend looking into this as well. Generally, these things can be bought for $35 or $40, and they're a little heavy, but they make a good system. ICOM occasionally comes out with a system like this. Shame on you if you buy it, because you can make this stuff. But if you want to go spend the bucks, it's available. Another system that can be bought. And another cot system as well, complete with band coils and coax and the whole 9 yards. And then there's this type of system with a cot system. It's close to homebrew, but I do have a similar one here. And I really like this. I've used this with my 214, but this system consists of just a clamp, the ground center poise. But the nice thing about this is you can tune it by moving this one main element out, and also this is like the Tar Heels antenna, but it moves up and down as a coil, and you can adjust it to where you've got resonance and lock it in, and it works. And I've used this on my 214, clamped a table like this in front of my garage, fired up, talked to a guy in Alabama. I mean, on 5 watts. Really, really nice system, actually. I don't know who makes it now. This is called the super antenna. I do see them around here last year. There's probably people this year. There's probably copycats. Just look around. I don't know who makes it, but it is a regional type of product, and whoever made this one did a really nice job on it. Okay, you might have seen this. You can take the regular TV ribbon. There are diagrams for that, or this is 300 ohm open ladder line, and you do it with a little bit of dissecting, cutting, and so on and so forth. You can make a really nice 2-meter 440 antenna that you can roll up and stick in your pocket. A lot of diagrams on the internet on that. Highly recommend it. It's a great antenna. This is, no kidding, not an April Fool's joke. This is actually an antenna. It's made from 2 coat hangers. And so on. Did anybody make this one here? Got some people saying, yeah. All right. No courage out there.
They have to be metal coat hangers.
Yeah, good point. you are joking, right? Yeah. Near vertical instant skywave antenna, NIVIS. These generally you can make them and package them up, but basically this is a dipole, but it is located close to the ground. And so as a result of being close to the ground, your signal doesn't go out at an angle, but goes out almost vertical with maybe a little bit of, Rick, probably a little bit of movement back and forth, but mostly vertical, right?
It's like a mushroom.
Mushroom, but lots of it going that way. And it goes straight up, hits the ionosphere, and actually comes down, not quite straight down, but far enough to hit over the horizon. So where you can't get in a local situation or a regional situation where you want to, let's say I want to talk over in Illinois into a deep area, a canyon area, and I can't get to it with 2 meters, I can't get to it with 440, you can get to it with a Nimbus antenna going straight up and down. And when Rick was working on his master's degree, we did that, and we were able to talk from my house here in Xenia over into Illinois via digital on less than a watt, and we had 100% copy. Yes? It looks like a dipole stretched on the ground, just a few feet above the ground. Yeah. Yeah.
How many is a few feet above?
5 feet, Rick?
We did it at 5 feet. It works really well at 10 feet too.
Not very
It's
far.
on top of plastic plumbing poles.
Yeah, on top of, I'm just going to amplify that. Yeah, using, if you go to the farm supply, you city slickers wouldn't know this, but yeah. You go to a farm supply, they have these temporary poles that you string electric line on to shock your cattle. Well, you can use those poles. Yes?
NVIS Day, NVIS Day they had for Ohio.
Yeah, good point. There is NVIS Day now where people get on and talk to each other to see how far they can talk on this, and it's pretty cool. What's going on? Oh, stand by for a second. I want to thank everybody here for their service as well. I know a lot of you are retired military, and a lot of you civilians are working in the business as well. We're very lucky to. That's one of the reasons why we have Hamvention here, is because of Wright Brothers and Air Force and the Wright-Patterson Air Force Base and the research labs. We employ about 40,000 people in the region. For those of you who are from out of town, so big deal. Thank you. All right, back to Nimbus. There you go. Then there's Homebrew, and I brought my tripod here. That has a 40-meter resonator on it, run the cable to the antenna. It'll work like it is, but it's better off if you throw some radios out as well. These can be made, but also there are tripods that you can make you can buy for roof mount antennas for houses and convert them. This one I made because I can drop it down and get it close to the ground and get really good capacitive coupling. Loaded whips, I showed you that. Back when the Yaesu 814 came out, there were a series of antennas made that are small loading coils like this. They're all available. They can be dropped on as well. And then, of course, there's dipole construction. Now, again, the dipole is the simplest antenna to build, and particularly when you're doing low band work, this is even more important. So I've illustrated here insulators that, again, are available in the area, but you don't need those type of insulators. In fact, a couple of credit cards or pieces of plastic will work, and I'll show you that in a second. Here's a case where it's just plain old pieces of plastic. If I want to get into building a low band antenna now, that is extremely important in an emergency situation. But okay, what time is this seminar end? Is it 11:15 or 11:30? Sorry? 11:40. Oh, okay, so we got a little bit of time. Okay. All right, I'm trying to adjust my time here.
What were you using?
I'm going to show you.
You just step right up here. Me? Yeah, sure. No, you didn't. I didn't mean to do it, Dad.
Yeah, but you're going to do it anyway. I need 2 more volunteers. I need the end posts here, so looks like, all right, there's one, and there's one. Okay, you guys go that way. You go that way, and we go that way. All right, can everybody hear me? All right. Scott, you hit yourself back there. I was going to use you, but that's okay. All right, so all I have here is a piece of plastic, and it's got a few holes drilled in it. And here I have a piece of coaxial cable. Now, this is really interesting. Back in the day before internet came over, whatever kind of lines that came over now, it used to come over coax. What was that called? And this is a piece of it they ripped out of a building, so it's 50 ohms, and it even had a connector on it, so I just robbed that. But what we have here is a plastic plate, and you can see I've got the coax strip to the inner conductor and the outer conductor. So if you hold that, you're going to really get an answer to this. All right, now I've got the other pieces already made for this out. I hope we got one here. And so, we already have one end of the line hole. And then here's the piece you had the question on. Just a piece of plastic with 4 holes drilled in it. Okay? That's your end insulator, and this doesn't count for this end. So, this would be a good question. How far? A couple inches. Yeah, an inch, just so they're not touching. You know, higher frequencies you'll get coupling, but not in lower frequencies. All right. All right, so you just hold this in, too. 40 meters? Nope, nope. There you go. 40 meters? Huh? 40? Yes. All right. You've been wondering what you're standing there for, right? Go that way.
The other end.
Go that way. Oh, yeah, yeah. You got your-
It's 67 feet, right?
When it's done, we may have to bend the corners here. All right, now, then on this end, again, this piece of plastic, could be a credit card or whatever. So just for strain release, you know, they go like that. Like that. Yep. I'm going to repeat what he's saying here in a second. So he did the same thing, but he went out, he's got cats, okay? So he went out and took a cat litter box and scissors.
The top of it is just cut it into squares, just, you had to put this together real quick. And that's what we use with our things. And we were using, this is like wires out at Home Depot.
Right, exactly. We use lamp wire. Then you twist that in on that one. And you twist that in on that one. And then hold that.
Now he fires up and puts 1,000 watts to it for it.
Anybody have a little yellow thing there?
What, the wire nut?
Yeah, wire nut, yeah.
Oh.
Well, I'm gonna get to this in a minute. In your go bag, you need to carry some wire nuts. These are just plain old wire nuts.
But this is for my safety.
And to make sure that this end is held down, just put the wire nut on that end. You need to tighten up and everything, let your center insulated, and you're ready to go. And we've got a 40-meter resonant antenna here. This can be lamp cord, this can be ordinary hookup wire, or whatever. It's just made out of a jump box. Now you're ready to go with a 40-meter emergency antenna, or you can cut it, bend it in half and make it 20 meters. What's your question?
Another question, so, since you're not using any type of ladder line or bending or anything like that, do you have to do any coiling on the end of the line to kind of balance it out, or do you just run
If you have a good question, since you're not using ladder on, is you could, now this is not the ideal situation. The ideal situation is put a ballon, one-to-one ballon in there, and so on. But in an emergency situation, the only problem is you might get an oblong signal coming out of this thing. However, if you have enough coax, about 6 turns of about 4 inches here, we'll make a nice enough choke that you can keep that from coming down the line.
But at the top or the bottom, like I can't seem to get on the forms online, like maybe.
I always put it at the top. And that just keeps, because this coax is unbalanced, and this is a balanced line, and so you'll have an unbalanced signal. So if you coil that, it'll keep the signals from coming down the line and crawling up into the transmitter. That can happen. Yeah, he said fair. If you want in your bag, put ferrites too. But in an absolute emergency, if you don't have it, this will work. Actually, in an absolute emergency, you can take this wire, ball it up, stick it in your coax connector, and put a ground line the same length. That'll work, and then suspend this end of the tree and throw your ground line on the ground, and that'll work as well. Not as good, but it'll work. The key is 468 over frequency in megahertz, right? Huh? Any questions about how to make an emergency dipole? Probably the most important part of this whole thing. And that this will allow you to operate on 10. You can cut it to whatever frequency you want. Made out of junk box stuff. Okay?
Are you gonna fire it up?
Huh? You want to fire it up? No. I can do that. Okay. All right. How far can you go with that end? Just have a little time to try this. You guys, if you do the body, you're going to corner this.
Six wraps. When you corner this, do 6 wraps.
4 inches wide. I'm not sure you have enough. 6 wraps at 4 inches wide.
All right, let me set this up. I said 20, so I'll put 7.2. Okay, we're going to have to get this thing up off the ground a little bit. Stretch it out. All right, we'll give it a try here. Okay. When the lights start blinking.
Okay, that sounds good.
All right, for some reason none of my analyzers don't want to cooperate. All right, let's move on here. All right. We'll clean this up here in a moment. Just drop it. Okay.
Do I do this? I heard it drop it.
All right, you also can take, and I didn't have a chance to do this, you can take 3/4 inch or ½ inch PVC pipe, cut it into sections and drill holes in it.
Use the mic.
Huh? Use the mic. I thought I was screaming loud enough. You can use PVC pipe as well, in a ½ inch or 3/4 inch, and drill holes in it the same way, and it'll make great antenna insulators. So, okay, probably should have did this before, but again, remember, 468 on 10 meters, do the numbers, and that's what you get. On 40 meters, we just did that. As you can see, it was pretty long there. So it's 32.5 on each end. You want to make it just a little bit longer, and when you do the resonant test, then you can begin to cut it. How do we do the resonant test? You don't have to have that fancy meter that didn't work, but you... You can go as simple as these little $15 SWR meters. So if you want to go that direction, you don't have to buy the $400 analyzers. You can do that with this, but you have to do some trials back and forth, and this will work just as well. So all kinds of ways. And then, of course, the radios today, many of them have the SWR meters already built into them. Okay, lastly, prepare for antennas for emergency purposes. You probably ought to build a go bag. I do have one assembled here if you want to come up and look at it later, but minimally, you ought to have a multi-tool or a knife, tape measure. Although, if you had to, most people, it's about a yard from this point to this point. Okay, so you can use that sort of if you got to. Rather use measurement, but it's almost exactly a yard from the tip of your finger to the to your nose, plus or minus, depending on how tall you are. And you can use any kind of lamp wire, 16-gauge wire, insulated wire. Doesn't have to be insulated. It's better. It's usually non-insulated. Gets all tangled up with itself. Good to carry some rope or bungee cords as well for your end insulators. Insulators, if you will, but as you know, if you got a plastic box, or a litter can or whatever. Wire nuts, coax if you can, and then if you want to get up in the tree, a slingshot or whatnot. So, as I said, aside from the transceiver, the antenna is the most important part of the emergency communication setup. If you don't have a good matched antenna, you're not going to get the signal out. You can build them up with just regular stuff out of your house, and you have to consider the emergency situation as well, whether it's local, regional, intrastate, or interstate. So, with that, we have a little time for questions, and also, I took it from the back, but up front here are some pencils and a paper that you can grade me on if you wish. And also, if you're interested in a different seminar next year, write it down, and I will, if I get enough for a particular subject, I'll do that. Okay. So questions? Yes, sir.
I know that I'm trying to make a 2-meter dipole. Use insulated wire instead of bare wire for a 2-meter dipole. It really changes the length.
Really?
Is it the same way on HF band?
Actually, no, and I really don't see it even affecting. Okay. Oh, he said insulation versus non-insulation affects the length. I might argue with you on that. I don't see, except in the very, very minute situations, that's an issue. Actually, you might have seen it, but I don't. I've used insulated, non-insulated, and have the same results. Yes. Oh yeah, I forgot to add that. A good roll of, it has to be black, because I had some red tape in here. Yeah, good idea. Huh? Yeah, electrical tape will work. Gaffer tape, what's that called? Duct tape? Duct tape cures everything. Yeah, you can patch leaks with it if you get cut and that kind of thing. Yes? Huh? My take on magnetic loop antennas, I wish I knew a little bit. If I had my buddy Ruben here, he could tell you, but I don't know. I just know they're circular and they got inductors and capacitors on them. Yes? Oh, he said, what's my take on magnetic loop antennas? I can't speak to that much, so if I did, I'd have to make it up. Yes? Yes. Okay, he said between PVC pipe, there's a rumor between the gray stuff and the white stuff. I don't know. I mean, the pigment might have an effect. Joe, you got some insight on that?
We ran into trouble with the 1296 beacon antenna with the gray stuff. It's conductive.
Okay, so I'm guessing, based on, Joe works in Air Force, or worked at Air Force, and they've done, in fact, military generally stays away from PVC on antenna outside because PVC will, just like when you put stuff in your microwave, it can oscillate and get hot under certain frequencies, and I don't know what that is. However, the difference in the two, the darker stuff probably has carbon in it, and that carbon probably resonates at a frequency that's going to give you a problem. So, yeah. Other questions? All right, I really appreciate the crowd. Good. Yes, sir, one more. Straight up. To go straight up, I'd say about 4 or 5 feet above the ground. You don't want to get it on the ground. Not in a NEMVA situation, but if you raised it higher, you get more gain going out. It's you're moving it up, you know, especially getting it up wavelength off the ground, then you get your maximum gain. Yes?
So I've got to go 80 miles. You have a recommendation on what band?
Yeah, 80 miles. You want to go 80 miles? I'd highly recommend Nimbus on 40. Yeah. Yeah, Nimbus on 40. I told him not to call me here. Yes?
NBIS antenna, this is magnet dipole is parallel to the surface of the ground. I made one that's PVC pipe about 10 feet, and then you
Okay.
antenna has got
10 feet, okay. He said, does it have to be parallel? No. You can put it at 10 feet and tie it down. I wouldn't put the ends clear on the ground, though. You don't want to get ground coupling. I'd say 5 feet off the ground. Yeah, that's bad. That's still Nimbus. Okay. Yes?
You didn't mention the 60-meter band.
60-meter band?
I thought about building a straight dipole 60 so that it resonates better.
Yeah, that's good. Just do the formula and do it. I'm not familiar with 60, but what's the frequency?
5,
Oh, yeah, 5.5 or something like that? 5.3 into 468, you got it. Simple as that. All right, thanks everybody, appreciate it. Papers up if you want to fill them out. So.